Number 1. A spherical balloon is inflated at the rate of 16 cubic feet per minute. How fast is the radius of the balloon changing at the instant the radius is 2 feet? And they're giving us the volume of the sphere formula. Okay, step 1 is write down everything they give us in the problem. First of all, they say the spherical balloon is inflated at the rate, so that's going to be a something dt, cubic feet per minute. Well, cubic feet is 3 dimensions, which means that's going to have to be our volume. So dv dt equals 16, and it will be positive because we're inflating the balloon. How fast is the radius changing? So they are asking us for dr dt. And then at the instant, the radius is 2, so r equals 2. So that's all the information in the problem. And then they did, next step would be a formula. Well, they nicely gave us the formula, so we're all set with that. Once we have our information and our formula, we're ready to take the derivative. So the derivative of v will be dv dt equals, and then the derivative of the right side, bump your 3 out front, so that's going to be 4 pi r squared dr dt. And now from here, we're just going to plug in what we know that told us the dv dt was 16. 4 pi, the radius was 2 squared, dr dt. So we're going to have 16 equals 2 squared is 4. 4 times 4 is 16 pi dr dt. And now we'll divide both sides by 16 pi. The 16s cancel. Please notice that the pi is left on the bottom. So it's 1 over pi. Or if you wanted to make that into a decimal, it would be 0.318. So dr dt equals 1 over pi, or 0.318. And radius is a one-dimensional object, so the radius was feet, so it's going to be feet per minute. And there we go. Number 2, a balloon rises at the rate of 8 feet per second from a point on the ground 60 feet from an observer. Find the rate of change of the angle of elevation when the balloon is 25 feet above the ground. Okay, first thing we want to do is write our information. A balloon rises at the rate of 8 feet per second, so that is how fast the y value is changing. So we know that dy dt is equal to 8, and it's positive because it's rising. And then it just says a point 60 feet from the observer. Well, that's already in our chart, and that's not changing, so we don't need to write it down. Find the rate of change of the angle. So they're asking us for d theta dt. And the balloon is 25 feet above the ground, so they are telling us that the y is 25. Okay, so we have our information. The next thing that we want is a formula. I notice this is a right triangle with theta. I have opposite and adjacent, so we're actually going to be using tangent. So tangent theta equals y over 60. And I'm going to rewrite y over 60 as 1/60th y, just to make it a little bit easier when I take the derivative. So now we have a formula. We're ready to take the derivative of it. The derivative of tangent is secant squared theta d theta dt equals the derivative of 1/60th y is 1/60th dy dt. Okay, so we have our derivative. Now let's start plugging in information. I notice as I start to try to plug things in, I don't have a theta. So what we are going to have to do is a little side trip to go find our theta. We do know that tangent theta is equal to, the y value in question is 25, so tangent theta equals 25 over 60. So what we are going to do to both sides is just take the inverse tangent. So we're going to take the inverse tangent of 25 over 60. You do want to be in radians when we do this. And when I do that, I get 0.39479. Please remember, in the middle of the problem, you must go at least 5 decimal places so that you're within 3 decimal place accuracy at the end. Okay, so now we have secant squared of my theta, 0.39479, times d theta dt, which we don't know, so I'll just leave it d theta dt, equals 1/60th times dy dt, which we know is 8. Okay, so now from here, secant squared theta is actually the same thing as 1 over cosine of 0.39479 of that squared. D theta dt equals 1 over 60 times 8 still. And now to solve for d theta dt, instead of finding this value first, I'm just going to multiply by the reciprocal of it. So d theta dt will equal 1/60th times 8. The reciprocal of that would be cosine 0.39479 squared. And notice where I have my parentheses, because we do want it to square the entire expression. So that's how we're going to type it into our calculator. And when we do that, we should get that d theta dt is equal to 0.114, and theta, we were working in radians, so it's going to be radians per second. Okay, number 3, a 20-foot extension ladder propped up against the side of a house is not properly secured, causing the bottom of the ladder to slide away from the house at a constant rate of 2 feet per second. How quickly is the top of the ladder falling at the exact moment the base of the ladder is 12 feet from the house? So we want to, the 20 is never changing, so that's already in my figure, but X is changing and Y is changing. So I'm going to go ahead and label those. Now let's put in what they tell us. It says the ladder is sliding away from the house at a constant rate of 2 feet per second. So it's telling us how fast the X value is changing. So dx dt equals 2. And then how quickly is the top of the ladder falling? So they're asking me for how fast is Y falling. So dy dt equals my question mark. And then it tells me that the ladder is 12 feet from the house. So my X direction is 12. So now I have my information. The next thing is a formula. This is a right triangle, so I'm going to use Pythagorean's theorem. X squared plus y squared equals 20 squared. And now once I have my formula, I'm ready to take the derivative. The derivative of x squared will be 2x dx dt plus the derivative of y squared will be 2y dy dt equals the derivative of 20 squared, since that's a constant, will be 0. All right, now from here, let's just start plugging in what we know. We've got 2 times 12 times dx dt, which is 2, plus 2. Now I came to my y and I don't know my y, so what we are going to do is stop mid-problem and take a little side trip. And we know that x is 12, so we'll have 12 squared plus y squared equals 20 squared. And so we'll have 144 plus y squared equals 400. If I subtract 144, I'll have y squared equals 256. And if you square root that, you'll get y is equal to 16. So now I can go back into my problem, plug in 16, don't know dy dt, that's what I'm solving for. So let's see, if I multiply that out, I'm going to get 48 plus 32 dy dt equals 0. I'm going to subtract 48, so I'll have 32 dy dt equals negative 48. And now I'll divide both sides by 32. We could keep it like that if you really wanted to. I reduced it to negative 3 halves, or we could make it negative 1.5. And y was just a measurement, so that would be feet, and then per second. And then we should be good to go with that one.